Hi, and welcome to Common Core Algebra II. I'm Mrs. Teets, and I teach here at Poughkeepsie High School. So thanks for joining us today. We're going to talk about equations of circles today, which is one of my favorite things to talk about because I love circles. I know they're not a function, but they're just so symmetric. I just love circles. Circles are so important in every aspect of life because even when you consider things like creating containers for things. A lot of cans come in circles because that way that you can maximize the amount of things you get in that cylinder and still be able to stack them. You do lose a little bit of room on the corners, like if you had boxes, they would stack a little bit more efficiently, but you maximize your volume by using a cylinder. So just a little piece of information there. So I want to recall that our distance formula, because we're going to be using that today, given 2 points, x1, y1, and the second one, x2, y2. The distance formula is basically given there. Now, this is not given to you on your reference sheet. You have to know this. So if by chance they ask you anything having to do with distance, you have to be able to recall this. So let's take a look at exercise 1. A circle is a collection of all points that is a set distance, which is called the radius, away from a point, which is its center. That's the definition of a circle. The circle shown below has a radius of 5 and a center at the point 4, 2. An arbitrary point on this circle, an arbitrary point just means any point that you can consider, xy, is shown in the first quadrant as shown on the graph here. So let's use the distance formula to show that point 7, -2 must lie on this circle. So I kind of gave you a hint by having you recall the distance formula, but if it is on this circle, it should be a distance of 5 because they told us that the radius of this circle is 5. So if we consider one point being 7, 2, and the other point being the center, which is 4, 2, and now we do our distance formula. So distance is equal to, doesn't matter which one you start with because you're just subtracting them. So let's do 7 minus 4 squared plus 2 minus 2 squared. I'm sorry, one of these is negative. It's 7 negative 2 right there. So this one is going to be -2 minus 2. All right, that makes more sense. So this is equal to the square root of 3 squared plus -4 squared, which is equal to the square root of 9 plus 16, which is equal to the square root of 25, which is equal to 5. So there we go. We just showed, so using the distance formula, show that that point must lie in this circle. So this right here is our radius. So we know that it must contain that point 7, -2. All right? So now in B, they said letting the first point be the center, which is 4, 2, and they're just saying let's pick that arbitrary point to be our second point. Write the distance formula for all points on the circle. So our distance formula is going to be the square root of x minus 4 plus, squared, plus y minus 2 squared, all right? And think about what this means. Okay, I don't want to get too far ahead because I'm going to talk about that a little bit in C and D. All right? So now if you look at C, C says square both sides of the equation from B. Well, if I have D is equal to, let's write this down again, x minus 4 squared plus y minus 2 squared. And now I square both sides. I'm going to have d squared is equal to, and we do that so we can eliminate that square root, x minus 4 squared plus y minus 2 squared. Okay, so square both sides of the equation from B to create the standard form of a circle. Now, our d squared, if you remember from our first problem, we're not going to call that d squared, we're going to call that r squared. So we have x minus 4 squared plus y minus 2 squared is equal to r squared. So we'll call the distance the radius. So this is the standard form of this particular circle. Now, in this particular circle that we're just talking about, it would actually be equal to 25 because we know that r is equal to 5. But I just want to keep something in mind here that we have something that looks like this, which is basically the formula for any circle, which should look familiar to this, where h comma k is the center. Now beware, hk, notice how it's h minus x minus h and y minus k. So when you're looking at our example up at the top here in our box, right here, you can see that we have x minus 4 and we have y minus 2. So our center for this one is going to be opposite signs, 4 comma 2, which is what we started with when we actually created it right here. All right, so show algebraically that the point 1, negative 2 must also lie on this circle. Well, we just said that the equation of this circle is x minus 4 squared plus y minus 2 squared is equal to r squared, which is 25 because r is 5. We're told that up above. So let's plug our point in, substitute it in. So we get 1 minus 4 squared plus negative 2 minus 2 squared is equal to 25. So we get 3 squared plus negative 4. Now be careful, make sure that's in parentheses, is equal to 25 because this right here will always turn positive because you're squaring it. So you get 9 plus 16 is equal to 25, and we just showed that that point lies on this circle. Okay? Write down what you need to, and let's get on to exercise 2. All right, so in the orange up here, this is what I was just talking about. A circle whose center is at h comma k and whose radius is r is given by x minus h squared plus y minus k squared equals r squared. So keeping that in mind now, in exercise 2, which of the following equations would have a center of negative 3, 6 and a radius of 3? Now, I'm not even going to look at my answer choices because I'm going to come over here and say, well, I know that my circle formula looks like this. And I'm going to have x minus my x value here. So this is going to be x minus a negative 3. So it's x plus 3. It's y minus 6 is equal to 3 squared, which of course we know is 9. So taking a look at this, now I go, because these look so similar. The only one that we know it's not this because it has to equal r squared. So that's a trap. Don't fall for it. So we know it's positive 3 and negative 6. So we can see that 2 is going to be the correct answer. Okay, these you should be able to run through pretty quickly. So I'm going to do the first couple, and then I want you to pause it, and I want you to go through and finish it up. All right, don't be concerned that you're getting radicals and maybe fractions, but just, it's not hard, okay? So for example, this is saying for each of the following equations of a circle, and I kind of don't have the top of this so you can see the directions. Oh, I don't have the directions here. I don't have them written down. So it says, for each of the following equations of circles, determine both the circle's center and its radius. If its radius is not an integer, express it in decimal form rounded to the nearest tenth. All right, so let's find out what the center is. So once again, I'm going to remind you, it's opposite signs on this. So it's positive 2, positive 7 is my center, and my radius is going to be the square root of 100, which is 10. Okay, Let's pick another one. How about F here? I don't want to do all of them for you, but very easily I can see my center is -6, +5, and my radius is going to be the square root of 18, which it's telling us to round this to the nearest tenth. So this is about using our calculator. So we put this into the calculator and you get 4.2426 to the nearest tenth is 2.4. I'm sorry, 4.2. A little dyslexia going on there. All right. Let's look at G real fast because I feel like G is a little disconcerting when we look at it because we don't see that H or that K. So our assumption then is our center must be 0, 0. And our radius is the square root of 64, which is 8. All right, so why don't you pause the video and write down the rest of these answers, okay? And then I will put them up so you can see them and check them with your work. All right, don't cheat now. So hopefully you did these before you're going to continue on with this video. Okay, so hopefully you didn't find that too difficult. All right. So let's move on to exercise 4. Okay, where is exercise 4? Oh, there it is all the way at the bottom, but half of it's not here. I don't know why it didn't show up. Okay, sorry about that, little technical difficulty. Here's our exercise 4. So write equations for circles A and B shown below. Show how you arrived at your answers. So if I take a look at circle A, all right, so let's take one circle at a time here. So let's take a look at circle A. Let's see, I know in circle A my center is 4, 1, and I know the point that's on the circle is 6, 4. And I need the radius, all right? So I need R. So how do I find R? By using my distance formula. So I know that R squared is equal to square root of 6 minus 4 squared plus 6 minus 4, 4 minus 1 squared, okay, which is equal to 2 squared plus 3 squared, which is equal to 4 plus 9, which is equal to 13. All right, so I'm sorry, I have R squared is equal, it's R, my bad. R is equal to, R is equal to, R is equal to. So remember that the formula for this now is area equals, what did we say the center was? 4, comma 1. So it's going to be x minus 4 squared plus y minus 1 squared is equal to 13. Because r was equal to the square root of 13, r squared is equal to 13. So there's my A. Now let's take a look at B and do that the same way. So for B, I know one of my points, my center, is -2, 4, and one of the points on this circle is 1, 8. Going to do the same thing. I know that the radius is equal to my distance formula, which is going to be 1 minus -2 squared plus 8 minus 4 squared, which is equal to 1 minus -2 is 3 squared plus 4 squared, which is equal to 9 plus 16, which is equal to the square root of 25, and r is equal to +5. So the equation of my circle B is going to be, my center was -2, 4, so it's x plus 2 squared plus y minus 4 squared is equal to r squared, which is 25. Keep going back to that. That r is a bone of contention here. So make sure that it's always equal to r squared. Determine what r is first, and then square it when you're setting up your equation. Okay, so that's it today. 15 minutes. I tried to keep it short. So tomorrow we're going to go over our classwork. This is not that hard, but it is something we have to commit to memory, that formula. All right, so think about what the formula of that circle is and really come in tomorrow being able to use it. Okay, have a good day and make good choices as always.